Okay. Thank you for that, Daniel, and welcome everyone to the webinar series for Bluey Technologies. During this one here, like Daniel said, I will cover across ground anchors, permanent, temporary, and removable anchors, some new technology into the marketplace for the removable anchors. So hope you guys enjoy. And like Daniel said, at any time, please jump in with any questions or type of question. Then you can see that during the day. So with ground anchors, what's the purpose of ground anchors and the applications for ground anchors? So ground anchors are an effective restraining device used in different types of structures. They're generally stressed anchor, active anchor, to prevent the structural movement of the basement of the building or the element itself. So, and the typically transfer the load over the fixed length, and these are known as tension anchors. And I'll cover that across a bit later on about the transfer mechanism. So where do we use ground anchors, both in permanent and temporary applications, as well as removables? Retaining walls, in dams, in walls, bridges, foundations, slope stability. So you can see there a few of the diagrams. They're used as tieback anchors underneath existing buildings for like station boxes being built in the civil industry. Also for permanent walls, so it's permanent anchors in the walls and in dams. They can be used in the dam walls, and also for the spillways, and also throughout the towers for wind farms and the likes as well. So it's a very wide range of applications for all the anchors, and these are just a few of where they can get utilised. How are anchors classified? So anchors are classified due to their service life, their purpose, the installation procedure, and also for the method of load transfer. Permanent anchors are classified in the way that they fulfill their function for the design life of the structure, and therefore they require comprehensive corrosion protection to justify the design life. So for a civil industry, you're looking at most of the structures have a design life of 100 years, where a commercial basement design life would be probably 50 years is the most common for a commercial building. So there's different levels of corrosion protection that are required for those different areas. Temporary anchors, they have a working life of up to 2 years. This is causing a little bit of conjecture in the marketplace at the moment. In the civil industry, where they're doing these temporary structures for the basements and the shafts, being classified as temporary anchors, but have a design life of 10 years. So there's a bit of issue back and forward between designers and authorities about putting in a temporary anchor, but justifying a 10-year design life for a temporary anchor, where all the standards say anything over 2 years must be classified as a permanent anchor. So removable anchors are classified as temporary anchors as well, for up to 2 years working life, but where they need their strands either being removed or have to be able to cut through later on after their service life is finished. So the type of ground anchors, typically it's a friction type anchor, and this relies on the friction between the grout and the ground to apply the forces. There's two different types. There's load concentrative anchors and then load distributive anchors. And I'll cover that in the next slides about how the load are transferred into the grout to the soil and why they're used for these applications. And both of them, both load concentrative and distributive anchors, can be a tension or compressive type anchor for the load transfer. So for a load concentrative type anchor, the load transfer, it's generally done over a fixed bond length, which is determined. The top image there, which I can show you here, that is a compressive anchor. So you'll have a distal end anchorage down the bottom of the hole, and the load is transferred from the bottom over the bond length. Where the most common is the bottom one here, which is a tension anchor. So over the fixed length, the load is transferred at the start of the bond length and then dissipates down over the whole length is there. So generally utilised within good rock and hard rock conditions, where the load distributive anchors there, you can see in the images, you've got different anchorage points to transfer the load over the full bond length. And then a load distributive anchor, these are generally for soft soils or weaker ground conditions, so you can actually transfer the load over the full bond length, where if you're trying to transfer that into a soft soil, you wouldn't get any bond or skin friction to transfer the load. So the transfer mechanism for these friction anchors, which is applied for the design calculation of the bond length. So this is the theoretical that you've worked out between the grout soil friction and the rock, and design bond length for the ground anchor. And this is actually showing you the difference between the actual load transfer and the difference between the theory and the actual. So what actually happens with a friction anchor in your top image there, you have a regional concentration of the load at the start of the bond length, and then, as we said, it dissipates in the load to the end of the anchor, and you can see there the difference between the actual, the theoretical and the actual. What happens? You get actual exceeds the skin friction of the ground, but it's only over a short distance, and there's a lot of reduction factors that are applied in the design, so you don't have any issues or any debonding at that point. The international standards or Australian standards that are applied for ground anchors, you've got AS 5100, which is a bridge design, which covers the geotechnical applications and reduction factors that get applied for the skin friction and the likes. RMS B114 is probably the most common specification for ground anchors throughout Australia, and gets used in New South Wales. It gets referred to in Queensland, as well as in Victoria as well, for the most comprehensive ground anchor specification for materials and application. And then throughout the rest of the world, BS 8081 is the British standard, and Eurocode are very similar, and they cover both the geotechnical and the application and manufacture of the anchors. Now we'll go into permanent anchors and what the anchors are consist of. So manufacturing of the anchors, and this is for all types of anchors, for permanent, temporary, and removable anchors, should all be manufactured under quality systems in a controlled environment. All your components should have quality control done from your sheathing, your grease, your strands, and everything as well. In-house testing facilities, so you can test the anchor blocks, heads and wedges to make sure that they're all compatible to the system. And there shouldn't be any site fabrication for temporary or permanent anchors. You can see there the photos on the right-hand side. The top image is showing anchors that have been manufactured in a factory coming on frames, and then you can see the site conditions the guys have to work into. So if you're trying to fabricate anchors on site and grease and sheave them for a free length, it's certainly not ideal, and is very common for the commercial industry that the anchors are manufactured on site and installed, so you don't have good conditions. You're not going to get a good quality anchor. In the civil industry, most of them are fabricated off-site in factories, like the image down below, so you can have it all done to the standards. They're all QA'd, and a high quality system is achieved. So what makes up a permanent anchor? So you've got the steel strands there. The two most common strands are the ASTM A416 and ASNZ strand 4672. I'll cover that off shortly, the difference between the two strands and why you can use both of them for both temporary and permanent within Australia. They have a free length, which is includes a grease section and sheathing over that section to give you a free length of strand. Your bond length with spaces, so you can get grout connection between all these strands. The standard set out what the minimum gap is between them all. Corrugated sheathing, there is a single or double layer depending on the design life and the application of the anchors, and I'll show you that shortly as well. And then essentially you have your bearing plate and your head and wedges for applying your tension and your lock-off loads. So with the single and double sheathing, you can see there in the images, this is the makeup on the left-hand side of your anchors. So you have your free length up the top, which has your sheathing and grease section to create your free length. And then down the bottom, you have your bonded length, which has your spaces to separate your strands to achieve your bond. And then the image on the right here shows your single layer sheathing and then a double layer sheathing there. The double layer sheathing is generally applied when you can't get back to, when you're doing a permanent anchor. The standards call for a double layer over the bonded length when you can't actually get back to re-stress and test the anchor over the 100-year design life of the permanent anchor. Not very common, but it does happen. We recently just applied that to some permanent ground anchors at Barangaroo with a double sheathing layer. So with the steel strands that we talked about before, all the standards within Australia call for the Australian NZ strand, sorry, 4672. We've recently applied quite a few temporary and permanent anchors utilising the ASTM strand, which is a common strand for anchors that are manufactured overseas and brought in. There's no real difference between them in the technical aspects of the two strands. As you can see there, they're both got good tensile strength, very similar, and we've actually justified utilising the ASTM strand for permanent applications on projects here. Like I said, with the Barangaroo project just done with the double sheathing, we're actually applying the ASTM strand. And the way we've basically worked out that we get the strands in and they get tested to the Australian standard to meet all the performance criteria. It gets tested locally, and it justifies the fact that you can use ASTM strand for the permanent applications. The sheathing specification. So this is a critical part of a permanent anchor to justify your design life, also your performance of the anchor as well. It's fairly strict criteria for the sheathing. You've got to have the right corrugations, the wall thickness, the pitch corrugations, and the amplitude. So it's a fairly complex way to get these manufactured as well. You can see the image on the right-hand side there showing the corrugations of the sheathing. It's done this way for a couple of reasons. One is for the load transfer between the grout and the ground, so you get good bond and you can transfer it over. If it was a straight sheathing, you would have the sheathing pulling out and have no load transfer to your ground. The other reason is for your application of your grout, so you can basically have it spiraling up the grout as it's getting applied and not having any air bubbles that get caught as you're doing your grout encapsulation of your anchor. And then there's a whole heap of specifications around the performance and the type of HDPE. There's quite a different materials out there with HDPE, and there's a very stringent criteria they have to meet from your tensile strength, your flexural modulus, your melt flow index, and your density to be classified for the permanent structures. And then your anchor head protection. Most of the permanent anchors have a cap you can see there on your left-hand side, which will be filled with grease. This allows to come back to the strands later on and re-stress them over the period of life if there's any creep over the design life. So they can remove the cap, reapply some stress onto those hedges, the head and wedges to reinstate the stresses on the anchors. And this is where we were talking about previously, where you have the double corrosion or double sheathing layer in structures where you can't have access back to them. Then they apply the double corrosion protection over the bonded length. So the permanent anchor installation. So the installation procedure for doing a permanent anchor or temporary anchor is drill and flush the hole. It's quite critical that you do flush the hole with water. You can see the image on the right-hand side there, the amount of pressure that you use to clean the holes out. Because you're relying on that friction, you don't want any of the dirt or debris left in the hole down there. You want a good clean surface to be able to, when you do your grouting, to make sure you get that load transfer. These anchors can be fairly large. You can be up to 40, 50 strands anchors and putting a lot of load, so a lot of transfer to your ground. You want to make sure you've got the best performance in your conditions. And then the anchor gets inserted into the hole. Before anything else happens on a permanent anchor, you have to do a water test to make sure you've got all your sheathing is there's to be no damage to there. So you fill the anchor up with water, and there's a 2 meter head difference between the internal and the external of the sheathing to make sure you get no water loss over 30 minutes. Once that's been done, then you grout the anchor up, and this is a very technical application for grouting the anchor because you've got the corrosion protection, which is closed off. You've got to grout the inside and the outside at the same time, so you don't get any pressures on the sheathing and have it collapse and cause any issues. So there is quite an art form to doing the anchoring and the grouting. Once the grout's been set, come up to strength, which is generally minimum you want to wait about 3 days before you're putting any stressing loads, so you get a good mature connection between your grout and your ground. You do your stressing and lock off, and then if you've got an exposed head, you do your anchor head protection with your caps after that. So different installation techniques. Because these anchors, ground anchors, are quite long, there's different ways of installing the anchors as you're going along. So the image on your left there shows the anchors being done by a crane. So they'll have it hung up and then lower it into the hole, which is okay for doing your vertical anchors. Another way of doing it is by having the anchors prefabricated, which is the middle image, onto a spoil, and then can be put in by a man or two. So this is a lot quicker, a lot less manual handling, and a lot less space is required to do this installation. And then there's the old way of having a lot of guys carrying the anchor, putting it into the ground. So not ideal, and not for a safety purpose. These anchors are quite heavy and large, and you want to reduce as much damage and fatigue on the guys as possible. So other considerations for permanent anchors when you're looking at these as hold down anchors or uplift anchors into basements, is the other connections that go along with that. So most of these places being permanent applications, you'll have waterproofing or tank structures. So we've actually come up with a way to do a 100-year design life connection with the waterproofing systems to these anchors. And that's the drawing in the middle there that shows the connections. So what we do a waterproofing connection, which we covered across in our waterproofing section previously webinars. That gets tested, QA tested and air tested to make sure we got a permanent seal onto the sheathing. And then we connect the waterproofing membrane up around it. So that way we've got a fully tanked basement with no water paths. The image on the left is what not to do when you're looking at these anchors. You've got a HDPE membrane there with a permanent anchor that's been put in place with sheathing and a steel bar, and all they've done is painted some black bitumen membrane over the membrane up onto the sheathing and onto the anchor. So that basement where that anchor was in, is 30 meters deep, so it's going to have a lot of water pressure there. So once I start dewatering that, you're going to have a lot of issues of water coming up through those anchors, and then you've got corrosion issues as well that affect that. So it's not only the anchor you got to look at, you got to look at the whole constructability of these anchors into your basements and connections. So now we'll go across to removable ground anchors. So this is an up and coming sort of market within Australia. It's very common around the world because there's a lot less space, and it's been around there for quite a long time. And why do we need removable ground anchors? Because we're encroaching on other people's properties. So you're doing commercial properties, they're going underneath someone else's house next door, or into rail authorities going underneath the rail corridor. They don't want to have anything left in the ground. There's a lot of costs associated with leaving strands underneath properties. Rail authorities charge you, other owners charge you to leave strand in there, because if they want to do some excavation later, then they've got to deal with the issues of having to cut through strands. So, and this is what can happen, and why it's getting specified more and more. To have removable ground anchors into the basements, so we're not leaving this sort of issue for future developments. You can see augers getting tangled up with strands can be very time consuming and expensive when you've got your equipment getting damaged like this. So the types of anchors for the removable market, there are manually removed anchors, which are the images on your top right hand side there. So these are removed by manual force, a lot quicker, easier, and safer to do. And then you've got equipment removable anchors, which is your loop or U-turn. So this is a very old technology, and that's your image there, your red casing down there. So basically your strand loops around the bottom end of it, and you need jacking forces on there to be able to remove that strand. And then your last option, which is a GRP or cuttable option. So this is not removed out of the ground. The GRP being able to be cut through, you can de-stress it and leave it in the ground. So this is a same multi-strand anchor, which you can do the same as the steel, but you can leave it in the ground. So, and I'll cover that a little bit more shortly. So U-turn and loop anchors. So these are a compression type anchor with the U-shape bend. Very old technology like we talked about, and becoming less and less. You can see there the image on your right hand side there. The reason why they don't get used as much anymore, because you need very heavy equipment to be able to remove the strand by force out of the ground. You lose strand properties in the bend, so that you need a lot more of these to do the same application, and you got limited working loads because of that bended application there. So, and very susceptible to damage, and then you can have your grease contaminating the ground, which no one wants to have. So the latest technology, which is the SAM removable RCD anchor. So it's world-leading removable anchor technology. You can have multiple strands, up to 24 strands for these removable systems. And like we talked about before, they're removable by human force. You don't need large jacks on there to do any removing the strands. And they've got extensive worldwide experience with over 2,000 projects in countries worldwide. I'll cover off the principles and how these systems work. So what you have with the SAM systems for removal anchors, you have anchor bodies like these, which are holding a single strand or double strands up to 6 strand anchors. And those anchor bodies are then spread out over the bonded length to transfer your load and create your bond zone. And then what happens down the bottom in these anchors, you have a barrel and wedge system, which allows you to put your tension on there for your active zones. Once you've finished, it's finished its design life, you go through, de-stress the anchors, rotate the strand, that will release this anchor here down the bottom, and then you can pull the strand out by human force. So it's quite a simple application. There've been quite a few projects that have been utilising that recently within Melbourne and Sydney for doing the removable anchors. So it's been quite successful applications. The GRP, so this is the other competing market. Instead of removing the strands, you can leave them in there using GRP. So again, this is a world-leading technology for the GRP strand anchors. They're multi-strands where traditionally you would utilise a solid GRP bar. By doing that, you're limited by length. You can only do 12 metres, then you have to do couplers. And when you're utilising couplers on GRP, it's not the best for doing ground anchors when they're being fully active. They don't transfer the same load as the bar. So I think having the latest technology of doing strand anchors with GRP has opened up a new marketplace. They're lightweight, they're easy to install, and there's no removal at the end of the day. So this is just an overview of the GRP. So effectively, one bundle is an equivalent to a steel strand. And it's got a 220 kilonewton capacity, a braking load, and it's made up of 7 individual GRP strands, which are 7 millimeters. Very lightweight. You can see the image down the bottom here, how they're assembled, the same as a multi-strand anchor. And this is just showing you the makeup of those GRP bundles. This is a connection piece, which you see here, which then connects to a standard steel strand for doing your stressing. Makes life easier on site for stressing with a steel strand and locking them off. Then they just de-stress them, leave them in the ground, and then they can cut through later on with no issues. So grouting of ground anchors. This is probably one of the most critical applications for all anchors, for temporary, for permanent, for removables, because it's all based on the grout connection to your strands, your sheathing, and then to your ground, which applies all your load. So it's generally overlooked and probably doesn't put as much emphasis on this when you're looking at that. Everyone's looking at the cost of the anchors, the application. But if you don't get your grouting right, then there's no point of doing your anchors. Like we said, it provides all your load transfer, your bond, and also your durability. So you can see there the photo of it is a cross section of a permanent anchor. I think that was a 35 strand anchor that was, again, double corrosion protected, 2 layers of sheathing. You can see all the strands there. There's no bleed, there's no loss of contact, there's no air bubbles at all within that grout. So the specifications, it's quite a stringent specification for grouting and the performance of the grout. There actually will be tomorrow's webinar, which Daniel will be covering across, which will be going through this fluid grout and all these specifications for around the world, for RMS specifications and the European specifications, which all cover the post-tensioning and permanent anchors. But this is just a quick little overview of what you need for a permanent anchor in your performance. So your bleeding, you've got a less than 0.5% bleed. Volume change, so it's got to be very stable. Early expansion, fluidity. This is probably one of the hardest things to achieve, is having a flow cone of less than 20 seconds and having it stable, maintain that flowability for 45 minutes, which is, you can do that by adding a lot of water, but then you have too much bleed. So that's one of the hardest things to achieve in the grout. And there's only a couple of grouts on the market that allow for this application that meet all the specifications for RMS and the standards out there. and then your strength for 32 or 40 MPa. So, and that's all. Thank you for joining us today. If there's any questions, you can either type it into the chat box down the bottom, or you can unmute and ask a question.
So thank you again. I'll end this meeting now for everyone, and enjoy the rest of your day.